To dive in, given the limited time we have available, I'd like to dive into this discussion of management of subversion projects. The discussion here relates to subversion. It also relates indirectly to a set of other version control mechanisms that make use of similar principles. Okay? So you'll see a general flow of work that's quite similar to things we'll be experienced with some other packages as well, where we're going to be focusing on subversion in our discussions of how you go about accomplishing these tasks with particular commands. Okay? Why am I covering this? Why am I dealing with version control and subversion for another lecture when you've already been given points of it? Well, there's two fundamental reasons. Reason one is that it's absolutely integral to the majority of software development projects out there. If you go into the internship program, if you come and work in a lab at the department, if you go and you go into industry following graduation, chances are good as not that you'll be using subversion again. Okay? And secondly, in your education, this class is sort of the opportunity to come to terms with it. To get comfortable with it, because later classes will assume this sort of knowledge. Okay, we're going to have it as featured on the exam, and it's going to be featured a little bit in some of the labs, as you've seen already. But the fact of the matter is that most of the demand for this will be outside the course, and it will be a day-to-day set of demands. You'll be using the set of processes I'm talking about here, whether it's updating, whether it's checkout, whether it's committing, etc. You're going to be using those on a day-to-day basis. Those of you who are going to take 370 next year, take Line 371, take 470, this is all part of the course. It's all assumed. We don't go over it in that class. So what I find is in 371, I find some students who are a little bit confused about some of the issues we're covering today. And I wanted to make sure you're really solid. I may also see if you're really solid with them in the exam. So it's a good chance to sort of come to terms with what's going on here. So, what is subversion? Who can tell me? Good. Version control program, or version management, another term for it would be change management. Another term you'll sometimes hear is revision control system. It deals with revisions to projects over time. So it helps you do the bookkeeping related to different versions of your program, different versions of particular files over time. Not just source code files, not just .c and .h files, but also things like, well, you tell me, what are some other things you might store in a version repository besides .c and .h files? Make files can be a big, critical one that programs in their own right. They're predominantly declarative. They specify what depends on what, but they can have a set of additional logic that extends beyond that. What are other things besides make files? Documentation is a great one. You may have documentation on the interfaces in your program, the contracts that are seeing documentation on what bugs are known, or what testing has been done. You might have a test matrix that describes the features of your program, what tests test out each of those features, so you make sure you don't have sort of glaring gaps in coverage. You might have statistics on your code coverage with programs. A lot of other things like that. What other things might live in a subversion repository? Configuration files, internationalization files, images for splash screens, all that sort of stuff lives in this repository. Why do we do so? Well, we do so for several purposes. You can give at least one purpose for keeping these things in the repository. Yeah, so many people can get access to it. We can share these things for each other. How about another reason? How if it's only yourself? Would you put something in a repository? Well, for a lot of programmers out there, the first thing they would do if they were starting out a project, they put it in a repository. Why?
Backup?
Yeah, backup. It's not on your hard drive. Your hard drive can die, and you still have it as access to a repository. So that's good. How about another reason? Well, it keeps track of successive versions of your program. So if you want to go back and you have a bug suddenly come up, then, and you want to check, was it there a week ago? Was it there 2 days ago? You can go back, you can get that version, you can make it, and you can see if it's there. Why would you do that? Why do you care if it was there 2 days ago? Isn't that water under the bridge?
Sometimes you're in a position where you need something to work now, and maybe it worked a day ago, and now you've done something and you're not sure why it broke, but it did.
Yeah, okay. So you might need it to work now because you have a demo for the client in half an hour. That's a good reason. So you might want to roll back to that version, revert to that earlier version, because you need it working now. That's a good reason, but what's another reason that was sort of tied up with your idea there? So I like what I was hearing. So suppose it's broken now, it's not broken then. Could you learn from that? What could you learn from being able to see what this program, see what the source code was for this program a day ago when it worked? Exactly. Take a look at the difference, the so-called diff. So we introduced a command when I first talked about this SVN diff that can take the difference between sort of what's in your working directory right now and what was there in some previous version. You specify the number. You could say essentially, show me the difference between what's here now and what was here a day ago. You can also do it between two versions a day ago and 2 days ago. That's also possible. But you could easily compare sort of what changed, and that might give you a clue as to where the bug was, where the logical oversight on why. Why are we seeing this error now? Some great reasons there. There's a bunch of others, it turns out. We might be interested in maintaining different versions of our code for different clients. We have the same underlying program, but we make one copy of it for Merrill Lynch. We make another copy of it for Goldman Sachs. We sell a lot of common logic, but we provide custom versions with custom features for them. And we don't have to do those with solitudes. We can actually capture the fact that there's 80% overlap between it. And just evolve for that 80% overlap, we don't need two copies. We don't need to go back and forth reduplicating changes. We can share a same set of copies. So there's lots of reasons for doing this. And I introduced Subversion as one way of doing it. In your professional lifetimes, then by the time that you folks graduate from here, Subversion will remain an important, very important player. Right now it is dominant. Certainly a year ago it was dominant. Right now it's kind of a little bit up to play. Git is rising quickly, and probably for the next 2 or 3 years you'll have a lot of sort of rivalry between them, but Git will probably end up being the dominant one in another 5 years by a significant factor. But today we're talking about Subversion, so it's a centralized version control system in contrast to Git's decentralized structure. It's open source, it is free, it's extremely popular. It's used by the majority of companies out there. The majority of shops use it, and there's a set of others that have similar sort of functionality that a lot of the same learning will apply. So I referred you to a good source on this, and I'm going to be drawing on some of the graphics that are featured in the source because they're quite communicative. This SVN book, which you'll find online, it's an O'Reilly Associates book to which I'd refer you. And I want to stress again, because this is absolutely core to be solid on this notion of a copy, modify, merge idea with these files. The idea here, folks, is that we can have several people working at the same time on some underlying file. So perhaps there's a file, integer.c, and Harry and Sally both get copies of this, and they want to modify it in different ways. Maybe one wants to do internationalization-related things, or wants to tweak up the user interface side of it, and the other wants to change some of the deeper logic. So suppose Sally's been working the deeper logic, she finishes first, and she commits it back to a repository. Okay? So she writes it to the repository. She commits her file, is the sort of operative term we use in this context. She does a commit. The idea here is that Harry has been working on the version that he got before, and he's modified it from A over here to A prime. Sally modified hers from that A to A double prime. She's committed hers. And what Harry's going to be doing is an attempted commit, but he's going to be told you get an out of date error. It's not compatible. In other words, you would overwrite Sally's changes. There's a conflict here. Say there's a merge conflict, a commit conflict. And so what he needs to do is he needs to update his file to get Sally's changes, and then he needs to merge them. And sometimes this can be done in an automated fashion. Sometimes it has to be done in a manual fashion. Sometimes, even when it's done in a automatic fashion, you want to double check. You always want to double check to make sure what it's done is meaningful. Okay? And then he can commit back his merge version, and both of them can refresh from that merge version and get their own files. Now, on a real life project, this refreshing from the code base, this getting updated files from the repository is done on a daily basis. Okay? That's a best practice. You want to keep if you're working on some piece of the program, you don't necessarily want to check in to commit that part of the program on a daily basis. After all, you may not be finished with it. It may be in a half-written state. If you checked it in like break, it wouldn't even compile. But what you do on a daily basis, and I want you to pay attention to this, what you do on a daily basis is not to check in for stuff, but to update, to refresh your code base so that you get things that other people have checked in. So Sally here finished her changes on this file a while back. Harry has been, he was working on his for a longer time, merged his with Sally's old changes. Now he's checked his in. And Sally is part of the discipline of regular builds will have on a daily basis refreshed her code base. So she would get this new file, which is great. She gets this new version of the file, and she works with that. Ladies and gentlemen, why is it important if someone out there has modified a file up there on the repository? Why is it so important that you go and get that on a daily basis?
You don't do the same thing we do.
Okay, so that's a good reason. You certainly don't want to duplicate their changes. You want to be able to know what's the up-to-date version of the file so that you don't end up duplicating some of their work. Excellent reason to do it. What's another reason? Good. Good. So, harking back to an example we've used in the past, maybe this is a file and it has, a square root function in it. And originally the square root function took in a double and it returned a square root according to the root finding model. So this is a square root and it gave some comments on what it did. And maybe what's happened is, so maybe that's what's currently in this file called square root.c on our system. That's what's there. But maybe sometime in the past half day, someone has updated this particular function and committed to the repository to add another argument, the tolerance. The precision with which we want the square root to be found. Now, if we have in our code a call to square root. Somewhere in our code we have a call to square root. So we're getting a square root of 2 or something like that. Would we want to know about this change? Is it important? Yeah, it's extremely important. Why?
That would break it.
Yeah. So what would happen, ladies and gentlemen, if we didn't update, we didn't get this latest version, but we instead just committed our code, which included this? What would happen? Suppose we said, we're done with this code. We're so done with it, and we check it in. What happens then? We commit it. Checking is another one. Yeah, who will it cause to have an error? Okay, so on the repository side, now this code we checked in alongside this other code in a different file. So this might be in square root.c here, and this code might be in, graphics.c or something like that, right? So we've checked in graphics.c. It has this call to the old version of square root. We have square root.c on the same repository having this version of square root that requires an extra thing. And anyone who gets both those files down and tries to compile will get a problem. This won't be able to be compiled because it's missing an extra argument. It's missing an extra number here, right? That's going to cause a lot of people problems. Now, in a rigorously done system, which again is par for the course for professional development shops, this would be caught on the server in what's called a continuous integration system. So as soon as you check this in, it's going to run a compile automatically. There's no one sitting there. Oh, I checked it. You go up to compile. No one typing G++ minus G, whatever. No one saying make all. It's all automated. It's all automated. And in 370, 371, particularly 371, you'll see the mechanism for that. There's a number of systems out there that will automatically manage these things for you. And when you check this in a system like that, it will automatically flag it. It'll say, bad news, you broke the build. In other words, you prevented the system from being built anymore. Now, when you check your code in, now you can't compile the system. So go back and fix. Go figure. Go fix your system. So it's extremely important, ladies, to not, ladies and gentlemen, you don't break the build. It's good to be to err on the other side. All too often in computer science, it's the reverse. And if I'm going to err, I'm going to err on that side. So here, ladies and gentlemen, ladies and gents, when we check this code in, if we haven't updated our code base, if we haven't got the latest version of this before we commit, we may break the whole system. We may put something out in the repository that can't even compile, much less run without bugs. If we put this up on the server, this code that includes square root of 2, we host the whole thing. Other people in the project aren't going to be able to build the system, they're not going to be able to run it for testing, etc. So it's extremely important, ladies and gentlemen, before you go commit your code, like this code for graphics.c, you update, in other words, refresh all the other files in the system that other people may have modified, so that you can, when you go compile, it will tell you about any problems. So you do an update, SVN update of your code base before committing. Then you would do a compile or a make, or generally, you'd compile your system, so I'm just going to say make, which may involve other processes as well. You make and you typically test it. And once you're confident that there's no obvious problems like this, we're wanting to compile, and that it works reasonably well, it passes what's called the smoke test, it passes a bunch of basic tests, then you can go commit yourself. But you gotta be working with the latest version of other people's code. Otherwise, there may be these hidden errors, which when you commit your code, mean that people can no longer build the whole project, can no longer do a make against the whole project. Okay? So it's extremely important that on an ongoing basis, and on a daily basis at least, that you are updating your code. So just like Sally here, at the beginning of each day, perhaps, does an update to get all those changes which have occurred since the previous morning by other people. It's very important that you make that practice on a real-life problem. Okay? Keep yourself up to date, because your code may depend on things that they have changed, and if it breaks your code, you want to know as soon as possible so that you can fix it before hosting the rest of the people in the project. Okay? Any question on that notion? Does that make sense to people? Okay. So we introduced a bunch of commands before that work with SVN, and I had emphasized some of them. So SVN import, what's that used for? Yeah, so suppose you want to go and you want to add a bunch of files into the repository to become a project in Subversion so that it will maintain these things. SVN checkout, what's that used for? Yeah, so okay, there's here at SVN import, we have a set on our local machine and we want to put them on the repository. SVN checkout, we have our local files, we have our local machine, and we want to start working on stuff that's in the repository. So we do a checkout on a project and get those files. Yes?
If a repository already exists,
yes,
and say, in your example, Sally adds a file to it,
yes,
and import,
yeah,
do I have to run update or checkout?
yes, you have to run update. If you already have, so if there's a repository of for some project. Repositories are for projects, right? For an entire project. So maybe this is the calc repository, right? And Sally has a version of this, and you have a version of this. So Sally is at one point checked out, gotten a version of this. You have checked out, got a version. And Sally adds a file. Okay? Suppose she had some testing-related file, right? She's going to do an SVN add to add that file into the project. But before that lands on your machine, so she'll do an SVN add here on that file, hopefully with a nice comment that says, you know, what this is testing or what have you. That will go back to the Subversion repository. So she did a checkout, now she's put that file back to the Subversion repository. But you may not even be online, you may be editing this form, you may be, editing it while you're on a plane or what have you. You don't see this sort of thing immediately. And in fact, until you do a command that will update your code base, refresh your code base, and that's SVN update, you won't see that file, okay? So you'd have to do, to get that file, you'd do an SVN update, and you'd do that at least once a day, and it would get that file for you. Does that make sense? Yeah, okay. SVN status gives some information on sort of what the recency of different files are. Are they for an earlier version of the code? But we'll see that in another minute, and a little bit more example. SVN commits our changes after we're confident they're worthy of being committed. They won't break other people's code. You don't commit garbage. You commit stuff that you feel is complete, compiles, tests, and you have reasonable confidence in it. That's when you commit it. And hopefully documented and then peer reviewed as well in a professional software system. Someone may be taking a look at it, either through pair programming or through a formal review process. SVN diff takes a differences between two versions of files. SVN log will sort of give you the history associated with a certain file or a certain branch of the code. SVN list can list the various things in the repository that you can go get. And so there's several others. SVN annotate to sort of put extra information on. SVN move to kind of change the name of something. SVN delete. And in fact, there should be an SVN copy, which is going to feature in our discussions in just a minute in a big way. So I'll put that there. Now, this sounds like a lot of work. Why do you have to do SVN copy? Why not just copy on your machine? Why not just do MV on your machine instead of SVN move? Why should you have to tell it, I want to change the name of this file? Okay, good. So if you just did an MV, you just changed the file's name. Could you do that physically? Yeah, you can do that. Sure. Change its name. The problem is, ladies and gentlemen, that it needs to keep track of the lineage, the ancestry of this file. It wants to know, oh, this was originally named that, and then it was changed to this other thing, and then this line was added, and this other thing occurred. And it does that so that it can merge things together more intelligently. Okay? It can sort of recognize against what to compare this when we're comparing two files. Against what other file in another branch of the code we're going to be comparing it. So it's really important that it understand from where a file originated. So if it had a different name originally, it wants to know that, and it will keep that information out in its log. And ladies and gentlemen, that will allow you to then roll back to that earlier version where it had a different name and do a diff, or do a diff and see, oh, this file called, square root.c, it knows it's the same file as is now called square root.c, and it will do a diff accordingly. SVN copy will be absolutely essential that it knows, oh, this file which has a different name has the same, originated with this other file, so that it can trace that ancestry back. We'll see why that's important in just a minute. Okay? It needs to be able to track ancestry. SVN delete can eliminate things. So we talked about the repository. It's a centralized store, and you've been accessing it on TouchWorld with a file, but in general, it's most commonly done with a server that's remote. Okay? For backup reasons, for sharing reasons, lots of other good reasons. This is very different, and I want you to be rock solid on this. Come to office hours if you're looking for additional discussion, because this is key. You have the repository there, and then you have a working copy of that. That's sort of your sandbox. It's the place that you're working on to make your changes, do exploratory work, etc. You don't necessarily want everyone else to see those things you've got going on in your local directory. Okay? So your working copy is the standard directory tree in your local system. You can fill it with files by doing a read, a checkout. And this is managed. It's managed by Subversion. It keeps secret information in the form of a .svn file. So if you do an ls-la, you will see a .svn file in a file where you've done a checkout, for example. And here, we can do a commit from here, and it'll get reflected in the repository. This is our own little private world to explore things we're going to be doing, and occasionally we're going to be pushing things up to the server so other people can share them once we're confident in them. Okay, and I noted SVN update is sort of reading from the repository. This is the thing you want to do on a daily basis. Ladies and gentlemen, suppose I had the final exam a true-false question that is recommended when you're using Subversion and version control that you commit your files on a daily basis. True or false? False. It's great if you can do that, but often we're working with tricky enough things that we don't have the luxury of doing that. It's great if you can, in the course of the day, make your changes, make sure it compiles, test them against broader suite of tests that we call the smoke test. Not something that your folks are required for, but something that the test talk about in 371. And do any documentation for it, maybe get someone to look over it and check it in. That's a great day's work. But it's often more than a day's work. And so we do not try to commit on a daily basis check. I suppose I had a question on the final exam and it said, true or false, that within a Subversion project, a project managed by Subversion version control, it's recommended that you update on a daily basis. True or false? True. True. You want to get that latest version of other people's files because your code, ladies and gentlemen, may depend on their code, and if their code is going to break your code, you want to know that as soon as possible. You don't want to wait a week until your code is ready to check in and then you do an update and you find 75 different problems. You want to know soon. Among those things, they did something which is a problem for you, go talk with them and head it off earlier. If they have done something which requires you to really rethink how you're doing your code, you want to know that as soon as possible. So doing updates early and doing them often is par for the course. And it's once a day at least, okay? At least. Okay. So we had talked about, okay, yeah, so this is, we had talked about how updates are atomic here. They occur either completely or not at all. They occur as a whole. They're monolithic, you can think, might be another word for it. They occur as a whole or they don't occur. If they fail, nothing has changed. You don't get some weird halfway state where 3 files have been updated, but 2 weren't updated. Yes?
Just on what's the idea behind the trunk branches?
We're going to be talking about the use of trunks and branches and some tags here in just a minute. So that's going to be a major part of today's discussion. Okay. So thanks for, and in fact, this slide is going to get us very close to that issue. So I noted that version numbers were present. So each commit creates a new state of the file system of the whole repository. Okay. And I want to emphasize these are revision numbers. When I check something in, conceptually there's a state of the entire repository that's created. And it's that state of the whole repository that the file number, or this revision number refers to. It's to that it refers to. It's not a version of the file. Okay? It's not a version of this particular file. It's a version of the whole repository. So I check in 3 files. There's a version of the repository created. Based on that, okay? And it's different than before I checked in those 3 files. It has those 3 files added to it, and that has a particular unique number associated with it. So you can think of it as kind of the state of the whole project at that time when I checked it in. Okay, you will see these numbers occurring occasionally, and sometimes they may occur in a way that's a little bit confusing. So, for example, last time we saw that we might be, for example, modifying some code, and we might introduce the first version of a routine called bar, for example, and we might do an update against foo and makefile. So we have the latest versions of those, but we're still operating off the first version of bar here, potentially. And so what this is telling us is SVN status update is telling us our version of bar is not the snapshot, not from the current snapshot of the repository. It's from an older version of the repository. And what that may mean is that perhaps Sally has modified it while we've modified it here. We may have to merge the 2 together. Okay. Okay. So I'd like to talk about some common workflows here. Right. So first thing is there's 2 main ways to populate the repository. I noted SVN import. You can also do SVN make directory and then do an add of a file. That's or an add of that the whole directory. Okay. So all the files in that directory. So this is a very, sort of common process here, common workflow that I've illustrated. We'll see one or two others of these before the class is out. So one of them is, okay, that you start with updating or checking out a working copy. So here you hold this copy. You will do a checkout if you haven't previously been working with a version of this. You may do an update. If you have been working, you want to get the latest changes. You'll make some changes. Maybe you add a file. You'll do SVN add. Maybe you want to delete a file. You'll SVN delete. So maybe you could merge two files which have been separate. You want to delete one of them, for example. Remember, it's going to know the full history of that file that was deleted. It can go back and retrieve it. But it's just in the new snapshot after an SVN delete, that file is not going to be present. SVN copy, which will create a copy conceptually of that file in SVN move, etc. Then you'll examine your changes. You'll see how have those changed things from what's on the server, sort of what's the current status of files compared to what's on the server, and possibly you'll undo some changes. For example, you revert back to an earlier version of the code. You'll undo some of the changes that you've accomplished. You might resolve conflicts, so you can do SVN resolve. It's useful for merging with other people's conflicts, following an SVN update. And then finally, once you're convinced that what you have is what you really want to commit to the repository, you can do an SVN commit. Okay. That will push to the repository your current version of one or more files that you specify, and it will make that repository consistent, the latest version of that repository consistent. What I want to talk about now, though, so are there any questions on this workflow? We're going to be talking about some issues of this in the context of branching that relate to this gentleman's question over here. So I want to talk about the use of branches and verges within these projects. This is a fundamental aspect of version control. It's something that is made easier, more conceptually straightforward, and actually from a performance standpoint, more lighter weight by virtue of how Subversion works. Okay? So you recall here that a revision is a snapshot. If a given revision number is a snapshot of all the files in the revision, they're associated with a particular number, right? So we're working on version 342 of this repository, and its repository as a whole. Often we will have one particular line of the repository, one particular folder or directory within the Subversion repository called the trunk. Okay? And this is it goes by different names. Our main line, our main development sequence, and this is where most day-to-day changes will go in. It's kind of our main line of development. Okay? And we'll have successive versions created along this main line as we go check things in, as we go copy things, as we go move things to rename them. We will create successive versions of the whole repository due to these changes along the trunk. Okay, so it's the result of changes on the trunk that we're going to version 12 or version 35. And that's where most people will be working. However, it will be very common for particular people, for particular subtasks, to create a branch. Okay? A branch can be created for many reasons. Fundamentally, it's going to be a persistent, ongoing line of development in parallel with the trunk. Now, why might you want to do this? Why might you want to have two lines of development going on at the same time? Did someone give me an example? I've mentioned two of them in class at one point or another, possibly more. Why would you want two sort of lines of development going on? Okay, so there might be lines between the two. There's certain things in common between the two, and we'll get to that, because Subversion automatically records what's in common between the two, which is really nice. But why might we want different branches at the same time? Why might Joe be working on one set of things, Mary on another, and Sue on yet another sort of line of development that might be associated with a different sort of version of the program, a different variant of the program? Why might we want to do that? Different platforms is great. So we have the Mac version of Excel and the PC version of Excel. They share some common code, but they have a set of files that are unique to each, for example, a set of needs that are unique to each. So I worked on that with the Excel team, and that's exactly what we had. So we shared files in certain distinct ones. What's another reason you might have this? Suppose it's all a Java project. It's all basically for the Java virtual machine. It could run on Linux, Windows, SunOS, any number of different distros of Unix. So why would you have different branches? Good. Yeah, that's a great. It's important. Another reason might be different clients. If you're doing semi-custom or semi-custom development, well, typically be semi-custom. You have one program and you customize it for this client this way, for that client the other way. You rebrand it for this third client in a different way. There's clients you might have at the same time. Even if you're not actively developing for them at the same time, you might need to support it for some of the earlier clients on an ongoing basis. And so you have a branch for each. So as I indicated earlier, you might have a Merrill Lynch branch, a Goldman Sachs branch, for different financial firms. And each would have essentially a copy of the source code associated with it, with some tweaks and bells and whistles for that particular client. Now, ladies and gentlemen, suppose you wanted to do this on your own machine. So forget about Subversion, too confusing. We're just going to do it. We're going to put the files up there on a Unix share, and we'll just have different folders for different clients. What's the problem with that? You have lots of copy pasting. So maybe you discover a bug that needs to be fixed in both code bases. So you go to the one from Merrill Lynch, you go to the one from Goldman Sachs, and you fix it in each code base, right? In some cases, you may have a lot of duplication of quite large things. Whole databases duplicated between the two, for example. Large image files or large data repositories that are shared in common, and yet you duplicate them in each subarea. That's not so desirable. Another thing you might have a branch for is if you do a release of your project. So if you do a release, so you post an app to the Play Store, right? Or you post an app to the Apple Store, and you posted it there, and that app is of a certain version. You want to be able to go on and maintain that version so you can fix bugs with it, for example. But meanwhile, you might be adding lots of features in for a later app release that just isn't ready yet, right? So you have a branch associated with that version that you've already released. And then you have a mainline trunk, which you are developing on an ongoing basis with nifty features that you're going to roll out in another few months but are not ready yet. And you need to maintain both. On the branch side, you're going to be doing the occasional fix and updating things in the store. On the trunk, you're doing your serious central development. The branch is more temporary, it's persistent, it might last a couple of months, but what might you want to happen at the end? You want to merge them, because then you're going to be ready to update this trunk. You're going to put that out in the Play Store. And all these bug fixes that have been going on here really should be reflected anyway in here by that point. You'll merge it in. Okay? You'll no longer require this as a separate branch. So let's talk about how that process occurs, okay? So we do this merge, and we'll see how that happens. I should distinguish this from a tag, which is sort of a way of denoting a certain unique snapshot of the entire project. So a tag is going to indicate, okay, this is the version 1.0 snapshot. But it doesn't have that persistence, that sort of ongoing character that's associated with a branch. We tag it, and that's great. It gives a clear label, lets us go back, and let's say we want to see exactly the 1.0 version. But often, ladies and gentlemen, you want to create a branch for the 1.0 version that starts with that snapshot. You want to go fix things. You want to roll out these maintenance changes on an ongoing basis. And it's for that reason that you'll have a branch, because there's ongoing development associated with it. A tag, by contrast, is just a label. It's a label for this version, for this particular snapshot of the code that we released to so-and-so. Very, very useful, but it doesn't give you that ongoing capacity updates. Okay, so I want to emphasize something that would be quite core to this notion of branches and merges, okay? The reality is, ladies and gentlemen, when we do an SVN copy from one file to another file, okay? So it's file 1, file 2, each prep's residing on the server, for example. The system's a lot smarter than just copying the bits. We're not just creating a copy of the file of equal size, in a different name, or load it, put it in a different place. Instead, what we're doing is we're actually telling it, hey, I'm going to create a new sort of version of this file, which is going to have a different name or be located in a different place. But it started with this file it's coming from. So it needs to recognize, okay, the ancestry of the file that we're creating. So maybe we're copying, a certain file, maybe it's, square root.c, that's in one folder. Maybe it's in the trunk. Perhaps it's in the trunk. And we're going to be copying it square root.c. So this little caret is used to indicate sort of the location of the repository. Maybe I want to copy it over to a certain branch. Maybe I'll call it well, because of space, I'll give it a short name, B1, and I'll copy the square root.c there. Okay. So now I have two conceptual copies of this, but it knows that this one, the result that's copied to, it knows that it originated with this guy here. And that's important because later we may ask to sort of merge it back into this, okay? So it knows that it's originated with this one here. And as a result, it's going to sort of allow us to do diffs from this original file. It's going to allow us to give a rendition of the entire history of this file, to roll it back to an earlier version, and it's going to allow us to easily merge it in when it comes time to merging in that branch. So one thing to realize is it's not just duplicating the bits. It's actually more like a link. It says, okay, I'm creating a new way to access this square root.c file. It doesn't need to save the complete copy. It just saves essentially a difference from the last version. And here, there's no difference at first from the version it came from. And if we go on and modify this in this other branch, it will be able to compare that to this original file. Okay? So it will know conceptually that you had square root.c, and it was modified for a while, and went through several different versions, and at some point it branched off to this one which was located over, so this may be in the trunk, and it went over to this other branch, B1, that's here, and it exists as an ongoing file there, which maybe goes through a bunch of different versions as well. So it knows this kind of history associated with this file, which is handy, particularly when it comes time to sort of merging what's going on here in the trunk into this. Let me get this out of people's way. So if you want to go later merge these two together, it's very important that it realize that these originated at the same point. It also lets you, as I say, show the complete history going back of where that came from. So often what we're going to have here is we're going to have a repository, and then we're going to have, within the repository, perhaps different subprojects, and we're going to have tags for that project, a trunk line for that project, and various branches. These branches may be versions that were released, which we now need to maintain. They may be versions for different clients, or what have you. So we're going to be going through an example where we're going to create a branch, we're going to work on that branch, and then we're going to merge that branch back in, okay? And this is actually from the book to which I referred you, and I suggest that you take a look at that example. It's fairly textured, and it will explain in quite some detail beyond what I'm able to capture here, what's going on in terms of some particular commands that are used to make this happen, and some of the extra detail on those commands. Here, what we're going to be doing is we're going to be creating a branch from the trunk, which is going to be a temporary branch while I work on some new feature, okay? But there's going to be other people going on and working on the trunk while I'm working on this feature. So maybe I'm adding in a feature to handle complex numbers or something like that, and I'm creating this calc branch for that because it's a deeper change. It's going to take me perhaps a week or two to actually deliver on it. And meanwhile, there's a bunch of other folks going on and fixing bugs up here, going on and getting it ready for internationalization or going and improving the strings which are used within it. So here we're going to have a series of successive versions, and it's important to realize that the version numbers are not necessarily contiguous here. So here we have, for example, the mainline trunk coming along, and then there's a branch at some point, and you'll notice these successive version numbers, these successive revision numbers. Again, those are numbers for the state of the entire repository, not the state of one particular file, but it's integer.c as it existed in this snapshot and another snapshot, all the way up to this point. And at this point, we branched off. So it was copied, and this started evolving, and this started evolving. And what's notable, folks, is that you notice this is revision 343, and this is 341, 344, maybe this is 342 here. You'll notice that this label is, again, a label for the entire repository, folks. It's not just for this particular file. And so, you know, you may get an interspersing of, as this thing got checked in, this was changed and committed, now you have version 343 created. Meanwhile, it's been going on, 344 is here. Those are the sort of labels for the entire repository as a whole. So we're going to have work going on here on my side, and we're going to have work going on by other people on the trunk side. And at some point, we're going to merge it in when my complex number code is ready to be merged in. So this is the basic narrative that we're going to follow. And this is going to be the last we're going to be talking about Subversion for now. So first, we're going to be splitting our code from the trunk. I want to get the copy, conceptually a copy of the project so I can sort of modify it for my complex number code without breaking everyone else's code in the meantime. Okay? So I'm going to do a copy of this. I am going to get a working copy associated with that project as part of that. So I'm going to copy this to a branch. I'm going to do a checkout on my side. And I'm going to then go on and make changes here. And I'm going to occasionally update everything. And in fact, during this process, I should have emphasized, I'm going to be committing. I'm going to be committing to my branch. That's why it's a separate branch. So I can commit to it, put it out there, get it tested, perhaps by testers, share it with some other people without breaking the overall trunk. Okay? And I'm going to be getting refreshes from the mainline trunk. Perhaps people have fixed a bug in the trunk. I want to get a copy of that fix on my corresponding file on my side, and eventually we're going to rejoin the branch to the trunk. I'm going to walk you through this process so you can understand it more basic. So we start in this situation where we have this calc project, and we have this trunk, and then branches, and we're going to do then an SVN copy to create a branch. Okay, and that SVN copy is going to be done on the remote system, and it's going to create a new branch. So it's going to be copied from someplace in the repository to someplace in the repository, and it's going to create a branch of this one. Conceptually, it includes each of these files. It really doesn't have to duplicate them in a full sense. There's no different than these files. And so we're doing this SVN copy. It creates this new branch. So that's step one. Step two here is to do a checkout. Why do we do the checkout? Folks, can anyone tell me? Why do we do a checkout? Yeah, you need it on my machine. You need that new branch, so it's on my machine so I can start to edit it. So before that, when we did this SVN copy on the remote system, that's great. The repository now has a copy. It has another branch. I need to get that branch on a particular folder in my system so I can start the product. I can modify it, right? So it's now on my own system. I can edit it. I could add new files in, etc. And I can add those files without worrying that people in the trunk are going to be modified by them. Okay. Now, there's going to be ongoing changes made by me to the branch and made by other people to the trunk. We're going to be editing these files and so on, okay? We're going to be going on and editing the files. And in fact, we're going to be committing as part of this, okay? We're going to be occasionally committing here. So edits are being performed in parallel up here and down here. This is my little branch, my little world for testing out my complex number implementation in this calculator. Meanwhile, other people are doing other useful things. And these changes are going on in parallel. I can commit my files down here, having to do with complex numbers, and they're not troubled by it. But by the same token, I might want to get some of their updates up here, right? Maybe they fix a bug that's in my version too, a bug with the real numbers. And I want to get those into my version. Maybe they go and they, put a nicer splash screen on, or they change the wording so that it's less confusing on some dialog box. And I want to get the latest versions of those. So even though we're working in parallel, even though they're not troubled by my check-ins, my commits, they are undertaking changes in which I might be interested. Okay, so during this process, I'm going to be doing occasional updates to get the latest version of other people's codes. I'm going to be doing a merge to get in the code from their side. So here, I'll do a merge, SVN merge, and that will bring in any changes to this file to the corresponding file here. Any changes to that file to the corresponding file there. Any changes, maybe this is, db.c, and we're going to merge that into db.c down here. So it's going to reflect these changes down here, okay? So I'm going to merge changes to the trunk into my own branch so I can get the edits, the bug fixes being done there. And then I'm going to inspect them to make sure they're indeed desired. What command will I use to inspect these changes? To see what changed as a result of the SVN merge? SVN diff will allow me to sort of see, okay, what changed here, what changed here, what changed there. Is that something I really want? Is it something that's compatible with what I'm doing? Okay, so, and if not, I can do an SVN revert to go back to an early version. Okay, so we've merged these changes in, and what I want to emphasize, folks, is how does it know which file corresponds to which? Like, how does it know to merge these changes for this file into the corresponding file here? The ancestry information. It's because it's tracked this information. No square root.c here originated with square root.c there. And so it knows, okay, it's the same file over here in the trunk that we have over in the branch. And so I can merge it in there. And even if I renamed it, even if in my branch I rename it to square root, with a underbar between square root.c, it would know it's the same file conceptually, so we'll merge them nicely. They play together nicely because it can maintain this history information. It maintains that information from whence it came, the provenance of the file. So that's what allows it to merge it in there. Okay, so I'm getting their changes, okay? Now note here, the direction of the arrows is such that my changes are not being made to the trunk. I'm getting their changes. And that's all well and good, but I still have my own little world here that I'm maintaining. Okay, so we're doing these, undertaking these changes, and then at some point, ladies and gentlemen, I'm not sure what happened here. I thought I had put it in red. We're going to reintegrate the two. I'm done with my complex number code. And ladies and gentlemen, when someone asks you in a software project, are you done with this task? It's not a matter of being done with writing the code. It's a matter of not just writing the code, but what? Testing it, sometimes documenting it, sometimes getting peer review for it. You certainly, even before you can test it, you have to compile it. All too often, software engineers, when someone asks them, are they done? It means, yeah, I finished typing in the code. But, you know, maybe it compiles, but it's not yet thoroughly tested. You want to be clear, being done means potentially all of those things, and at least having tested it so you can pass the red face test, that yes, it works. Okay, so here we are seeking to rejoin the branch. So here we'll do something called SVN merge -- reintegrate. Okay, and actually there's an extra space here, which there's. So integration basically will merge together this branch back into the trunk. Okay. Ladies and gentlemen, how does it know where to reintegrate it? How does it know where to put it back? How does it magically know, oh, it has to be placed over here? Sorry? The ancestry. It knows from whence it came. It knows that it copied it from the trunk, and back to the trunk it will go. It has memory, just like an elephant. Okay. Okay. So here we do SVN merge -- reintegrate, and it will actually integrate that code back into the trunk, so that other people can now get the results of my contributions, and this branch should no longer be used. Yes.
What happens if you merge the wrong way? For example, file number 1 with number 2. What happens? You get an error or something?
If you do. Yeah. Right. We know the correspondence of files.
And what happens if you do it the wrong way? For example, file 1, file 2.
Okay, you could do something whereby you could go and
you might by mistake you do that. So
right. You could copy this file there, but you're not going to be able to do reintegrate. In other words, you can't tell it, for example, reintegrate this such that these guys are reintegrated with this, because there is no branch from this place. So it's only going to allow a reintegration of a branch with something from which it came. Okay. Otherwise, it's going to say that doesn't make sense. You can't do that sort of thing. Yeah.
So if you have a branch and you branch off that.
Yes.
And you reintegrate
Yes.
that with the first branch.
Yes, that's right. You could then reintegrate it with the first branch. The key thing is that there's this SVN copy which created this branch. It's the SVN copy that gives that information in the ancestry to allow it to reintegrate effectively. Does that make sense? Okay, ladies and gentlemen, so those are great questions. I will cover this